Greetings everyone. In this practical, we are going to demonstrate practical number 31 in our A-level physics syllabus. We are doing this practical to determine the electromotive force and the internal resistance of a dry cell. This is a commercially available dry cell of known EMF 1.5. As the power depletes, the electromotive force of the dry cell changes. We are doing this practical to find the actual value of the electromotive force. Here, the two dry cells are connected in series to obtain enough potential to get very large range of readings. This is a tap key. We are using the tap key to avoid the circuit from heating up due to continuous flow of current, which could in turn affect the readings. This is a rheostat and this has three terminals. We are connecting in the first configuration by connecting to these two terminals. When we move the slider from right to left, the resistance of the circuit increases as the effective length of the rheostat increases. If we move the slider from left to right, the resistance of the circuit decreases because the effective length decreases. By connecting in the second configuration, if we move the slider from right to left, the resistance of the circuit decreases, and if we move the slider from left to right, the resistance of the circuit increases. This is a voltmeter. This is used to measure the potential difference between 2 points, and this has a range of 0 to 5 volts and a least count of 0.1 volt. When connecting the voltmeter, it should be connected in parallel with the dry cells. When connecting the voltmeter to the circuit, the polarity of it matters. The positive terminal of the voltmeter should be connected to the positive terminal of the battery, and the negative terminal of the voltmeter should be connected to the negative terminal of the battery. This is an ammeter. This has a range of 0 to 1 ampere and has a least count of 0.01 amp. And when connecting the ammeter, it should be connected in series with the batteries, and when connecting the ammeter to the circuit, the polarity of it matters, similar to the voltmeter. The positive terminal of the battery should be connected to the positive terminal of the ammeter, and the negative terminal of the battery should be connected to the negative terminal of the ammeter. The above diagram illustrates the schematic symbol of a dry cell, and if two or more dry cells are connected together, it is known as a battery. The electromotive force of a battery is equal to the potential difference across the terminals when there is no current flowing through the battery. Here the potentiometer reading shows the potential difference across the battery's terminals where it is equal to the electromotive force. The above schematic diagram shows the circuit used for this practical. The electromotive force of the battery is equal to the sum of the voltage across the battery and the product of the internal resistance and the current flowing through the battery. If we rearrange the equation, we will get the equation V is equal to minus R into I plus E. Here I is the independent variable and V is the dependent variable. Now we've obtained an equation in the form of Y is equal to minus mx plus C. If we plot the points with the set of readings obtained by doing the practical and by drawing a best fit line through all the points, we could find the gradient of the line. We should mark 2 points on the best fit line other than the data set, such that they are half the distance of the best fit line apart to calculate the gradient. By constructing a right angle triangle, by taking this angle as theta, the tangent of this gives the gradient of this graph. By calculating the intercept, we could find the electromotive force of the graph, and while the gradient gives the internal resistance of the graph. Now to plot the graph, we need at least 6 points, but for the sake of accuracy, we are getting minimum of 12 points. While holding down the tap key and by moving the rheostat, we could get 12 sets of readings for the voltmeter and the corresponding reading on the ammeter. And first we are getting a reading on the ammeter of 0.5 amps and the corresponding reading on the voltmeter to be 2.2 volts. For the second reading, we are getting a 0.15 amp and the corresponding reading on the voltmeter to be 2.8 volt. Similarly, we can repeat this procedure for other 10 readings and obtain other 10 sets of readings and plot the graph. Here we are displaying the 12 sets of readings obtained by doing the practical. By doing this practical, we have found out the electromotive force of the batteries to be 2.85 voltage and the internal resistance of the batteries to be 1.86 ohms. Thank you for watching our video. Please stay tuned for more practical videos like this.